All right, ladies and gentlemen, today we're going to be talking about three things. First thing we're going to cover is our unit circle in radians. So I want to give you guys a trick for remembering how to label it in radians. Second thing we're going to look at is right triangle trig again, and then third thing we're going to look at is circular trig. So three topics. First one we're looking at is the unit circle. So the unit circle, we started out with 0 degrees, and then we said plus 30, plus 15, plus 15, plus 30, and so on. Well, now we're going to start looking at that in radians. So the first thing I want to do is convert 30 degrees into radians. So I know that if I do 30 times pi over 180, I get pi over 6. So I know that 30 degrees is the same thing as pi over 6. So I'm going to go ahead and fill in pi over 6 next to 30 degrees. Let's see here. I'll go ahead and write it here. Now every time I add 30 degrees, I'm adding pi over 6 radians. So here is my first spot that I have 30 degrees. If I add another 30, I end up here. Add another 30, I end up here, add another 30, add another 30, and so on. And I'm going to color code around my unit circle like this to help me label. Now every time we add 30 degrees, we're adding pi over 6 radians. So pi over 6, add another pi over 6, we end up here at 2 pi over 6. We add another pi over 6 and you end up here at 3 pi over 6. And these are our radian measures for our angles. Okay, we've got two ways to measure angles, degrees and radians. So 1 pi over 6, 2 pi over 6, 3 pi over 6. When I get here, now I'm at 4 pi over 6. And now here this is 5 pi over 6. And this guy is 6 pi over 6. And then 7 pi over 6. And it keeps going. 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6. And if I add one more, I'm back here at 12 pi over 6. So 0 radians is the same thing as 2 pi radians, because 12 divided by 6 is 2 pi. Now the next thing I'm going to do is I'm going to convert 45 degrees into radians. So times pi over 180, you get pi over 4. So right here in the middle, 45 degrees is the same thing as pi over 4 radians. Now I add another 45 degrees, and I'm up here at the top. Now notice that they overlap, but that's okay, because if I have pi over 4 and I add another pi over 4, I get 2 pi over 4. But 3 pi over 6 and 2 pi over 4, they simplify to be the same thing. So I start at 1 pi over 4, add another 45 degrees, which is the same thing as adding pi over 4 radians. So I'm 1 pi over 4, now I'm at 2 pi over 4. Now another 45 degrees, I add another pi over 4, which is 3 pi over 4. And I'm going to continue going around my unit circle. 4 pi over 4. 5 pi over 4. 6 pi over 4. Oops. Okay, here we are at 7 pi over 4. And then back up here, they overlap, and that's 8 pi over 4. Now the last thing you need to do is just simplify everything. So I'm going to go through in red and simplify. So pi over 6 is already simplified, pi over 4 already simplified, 2 pi over 6 simplifies to be pi over 3. 3 pi over 6 and 2 pi over 4 simplify to be pi over 2. 4 pi over 6 simplifies to be 2 pi over 3. 3 pi over 4 is simplified. 5 pi over 6 is simplified. 6 pi over 6 and 4 pi over 4 become pi. 7 pi over 6 is simplified. 5 pi over 4 is simplified. 8 pi over 6 becomes 4 pi over 3. 9 pi over 6 and 6 pi over 4 both become 3 pi over 2. 10 pi over 6 becomes 5 pi over 3. 7 pi over 4 is simplified, 11 pi over 6 is simplified, and 12 pi over 6 and 8 pi over 4 both become 2 pi. So 360 degrees is the same thing as 2 pi. So here is your unit circle in radians. I know there's a lot going on here, but that's the pattern. Plus pi over 6, plus pi over 6, plus pi over 6, plus pi over 6, and so on. And then for the middle angles that are multiples of 45, you go plus pi over 4, plus pi over 4, plus pi over 4. Okay? So there we go with that. Now, next thing, I want you guys to have WebAssign open while we're taking notes here, because we're going to take notes and then we're going to do a practice problem and so on. So first thing we're looking at is right triangle trig. And you guys already know this. Well, you know 3 of the trig functions because we've been doing SOHCAHTOA for quite a while now. So I'm just going to reiterate that sine of theta is the opposite side over the hypotenuse. Cosine of theta is the adjacent over the hypotenuse. And then the tangent of theta is the opposite over the adjacent. Now, in addition to these 3 original trig functions, so I'm going to call these the original trigs, you have your reciprocal trig functions. So the reciprocal functions are literally just flipping the originals. Now the reciprocal function for sine is called cosecant, and it's abbreviated CSC. So that's just the hypotenuse over the opposite side. The reciprocal for cosine is secant, and that is SEC, so secant of theta, and that's the hypotenuse over the adjacent side. And then the reciprocal for tangent is cotangent. And that's abbreviated COT, so cotangent theta equals adjacent over opposite. Now let's look at how that applies here. So I'm going to do an example that's very similar to what you see on your WebAssign. So let's say I give you a triangle like this, and let's say this is my theta up top, and I call this 5, and I call this, no, let's call that 6. Actually, I can't call it 6. Let's do 2 here. And I want to find all of my 6 trig functions for this angle theta. So I need to find sine theta, cosine theta, tangent theta, cosecant of theta, secant of theta, and cotangent of theta. So in order to find all of these, I need this third side here. So how are we going to find that third side? So we're going to use the Pythagorean theorem. So I'm going to say 5 squared equals 2 squared plus, we'll call it x squared. So 25 equals 4 plus x squared. So I get 21 equals x squared. Take the square root. When you add a square root, you have to add plus or minus. So x equals square root 21 or negative square root 21. Now you know we're doing the side of a triangle, so we don't want the negative answer. So I'm just going to use this positive one. So sine, opposite over hypotenuse, so we get 2 over 5. I'm going to immediately do cosecant, which is the reciprocal, 5 over 2. Cosine is adjacent over hypotenuse, so square root 21 over 5. I'm going to immediately do the reciprocal, which is 5 over square root 21. I'm going to rationalize my denominator, so square root 21 over square root 21. So I get 5 root 21 over 21. Tangent, opposite over adjacent, so we get 2 over square root 21. When I rationalize my denominator, that becomes 2 square root 21 over 21. And cotangent, I'm just going to flip my tangent, so that's square root 21 over 2. So these are going to be your answers here. Now I want you guys to go over to WebAssign, and you should be able to pause the video, and you should be able to do number 1 and number 2 on the WebAssign. I also want you guys to try number 3. Number 3 is asking you to reach back for special right triangles, 30, 60, 90. So pause the video and do number 1, 2, and 3. Okay, so let's look at another type of problem now. And this is still in right triangle trig. We haven't touched circular trig yet. So let's say we have that sine theta equals 7 over 9. And I want you to find all 6 trig functions for this theta. And let's say theta is an acute angle. By saying that it's an acute angle, that means that I can assume that it could be in a right triangle. So I'm going to go ahead and draw my right triangle. Doesn't matter where you put theta. I'm going to put theta on the bottom this time. Now if I know sine theta is 7 over 9, this is my opposite side, and this is my hypotenuse. So opposite from here is 7, the hypotenuse is 9. Again, to find the third side, you need Pythagorean's theorem. So 9 squared equals 7 squared plus b squared. So we get 81 equals 49 plus b squared. So 81 minus 49 is 32 equals b squared, square root, add my plus or minus. So b equals positive square root 32 or negative square root 32. And you guys know that we don't want the negative answer. I'm going to simplify my radical. So this simplifies to be 4 square root 2. If you forgot how to do that, then you can ask me separately, but that's just an algebra 2 skill, simplifying your radical. So this ends up being 4 square root 2 here. Now, let's go and fill in our functions. So sine, cosine, tangent, cosecant, secant, and cotangent. And the way that I remember that cosine and secant go together, I remember it because cosine starts with a C and an S, and the secant starts with an S and a C, so they both have C and S in the beginning and end. It's just how I do it. If you have another trick, then share. Otherwise, mine might help you. Maybe, maybe not. Okay, anyway, sine theta. Sine is opposite over hypotenuse, so 7 over 9. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. I'm going to rationalize my denominator. So I get 7 square root 2 over 8. Cosecant, instead of opposite over hypotenuse, is hypotenuse over opposite. Cosine, instead of adjacent over hypotenuse, it's hypotenuse over adjacent. I'm going to rationalize my denominator. So we get 9 square root 2 over 8. And cotangent, instead of opposite over adjacent, it's adjacent over opposite. So there you go. All right, so now come back to your WebAssign, and you guys should be able to do number 4 now. So pause the video, do number 4, make sure you understand the concept, and then come back to the video. All All right, so our next concept and the last thing we're talking about is circular trigonometry. Now with circular trig, that's where the unit circle starts to come in. So let's think about what we did on the unit circle. In this circle, let's say I have this point here, x comma y. That point's x comma y, that means this is x and this is y, and here's our radius of the circle. The radius is always going to be positive. While x and y can be negative depending on what quadrant they're in. So if I think about this, sine theta, where this is our theta, theta is always going to be next to the origin, is going to be opposite over hypotenuse, which makes it y over r. Cosine theta is going to be adjacent over hypotenuse, which makes it the x value over the radius. And then tangent of theta is going to be the opposite, which is y, over the adjacent, which is x. And if I think about my reciprocal functions, this is going to be r over x. This is going to be, r over y. This is going to be r over x, and then cotangent is going to be x over y. Now let's look at how that applies to a problem. So let's say I tell you that the terminal side of an angle lies on the point -2, 3. And I want you to find all 6 trig functions for that theta where the terminal side lies on -2, 3. So first thing I'm going to do is I'm going to think, okay, my radius, I don't know. And I'm going to draw a picture here. So -2, 1, 2, 3. Here we are. So there's that point, and I can draw a triangle out here. This side is -2, this side is +3, and my radius of this circle ends up being the hypotenuse of this triangle. So if you imagine, this is circular trig because you could essentially draw a circle here where this point is -2, 3, and you see how it lies on the terminal side of that angle. So by definition, we have up here in the top all of the ways that you find your sine, cosine, tangent, etc. But I need to know what this radius measures. So I'm going to do Pythagorean's theorem. So we're going to get 3 squared plus -2 squared equals the radius squared. So 9 plus 4 equals r squared. 13 equals r squared, square root, add your plus or minus. You know you only want the positive one, so the radius is square root 13. So this guy here is square root 13. And so now I'm just going to figure out all my functions. This reference angle represents your theta here. So sine theta is -2 over square root 13, which is -2 root 13 over 13. And you can also just think about that as your x value over your radius. Cosine theta, oh, I'm sorry, this is sine is 3 here. So opposite over hypotenuse. Cosine is adjacent over hypotenuse, or the x value over the radius. That's going to be -2 root 13 over 13. Tangent theta is 3 over -2. And then we'll do the reciprocal functions. Cosecant theta is square root 13 over 3. Secant theta is square root 13 over 2. And cotangent theta is -2 over 3. So now, once again, pause your video, go back to WebAssign, and number 5 is a circular trig function where they give you the point. Okay, so now come on back to the notes and let's talk about how this applies to the unit circle. So on the unit circle, we've got all of these points in here. I'm going to come back to this first example that we always draw in the first quadrant. Our radius here is 1. So we had said earlier that if I try and find cosine of theta, it ends up being x over 1, which is just x. And that's why this part here, whatever that value is on the unit circle, only in the unit circle, this represents cosine of theta. And we had said sine theta is opposite over hypotenuse, the y value over the radius, and in the unit circle that ends up just being y. So what we have here is that this value, the y, always represents the sine of theta. So let's say I have the question, what is sine of 30 degrees? Well, what I'm going to do is I'm going to go to my unit circle. I'm going to look for 30 degrees. Well, 30 degrees is here. And the point there is square root 3 over 2, comma, 1/2. Now remember that the sine is your y value. Okay, sine of your angle. So sine of 30 degrees is 1/2. So I would just say that equals 1/2. And it's that easy. Let's say I want to know tangent of 90 degrees. Okay, well 90 degrees is up here. The coordinate there is 0, 1. Tangent is the y value over the x value. So 1 divided by 0. And that's undefined. So tangent of 90 is actually undefined. Whenever you have 0 in the denominator, you get something that's undefined. So let's come over to your WebAssign again, and let's look at some of these last problems here. So my first ones, I'm going to skip down to part B where it says negative 810. So before I actually start, I'm going to add 360 as many times as I need to get a coterminal angle that's between 0 and 360, so I can know where it is on the unit circle. So coterminal with this is 270 degrees. So on the unit circle, 270 degrees is down here at the bottom. My point is 0, -1. So that means that the sine, which is the y value, is just -1. Cosine is the x value, which is 0. So sine is -1, cosine is 0, tangent is the y divided by the x, so it's undefined. Now, on the unit circle, to get cotangent, I'm going to do x divided by y instead of y divided by x, so 0 over -1, which is 0. Now I'm going to pause here for a second and come back to the notes. So what we did was sine, tangent, etc. I'm going to erase this part here, and we're going to write some shortcuts for using the unit circle to find your trig functions. So we said cosine theta is x. We said sine theta is y. Tangent of theta is y over x. Now, to get cosine of x, to get secant of theta, all you're going to do is flip the x value. And I'll show you what I mean by that in a second. To get cosecant of theta, you're going to flip the y. Because cosecant's the reciprocal of y, and secant's the reciprocal of cosine. You just flip those values. And to get cotangent, you're going to do x divided by y instead of y divided by x. So an example of what I'm talking about is, let's say I ask for secant of 60 degrees. So I go to my unit circle and I think about 60 degrees. 60 degrees is up here. So the point is 1/2 comma square root 3 over 2. Now secant is the reciprocal of cosine. So all I'm going to do is I'm going to take the cosine, the x, and I'm going to flip it. So instead of 1/2, I get 2 over 1. Because secant's the reciprocal, so we just take the reciprocal of cosine. And that's all I mean when I say flip. So when I come back here to Webasine, secant of negative 810. So I'm flipping the cosine value. Now there is no denominator here, so I want to think about the denominator as just being 1. When I flip that, I get 1 over 0, which is undefined. Cosecant of negative 180, so I'm going to flip the sign. So sine is negative 1 over 1. I'm going to flip it, it stays the same. So it's just negative 1. Now, 10 pi, let's think about 10 pi here. 10 pi is not on the unit circle. Instead of adding and subtracting 360, I'm going to add and subtract 2 pi because 2 pi is the same thing as 360 degrees. So 10 pi minus 2 pi is 8 pi, minus 2 pi is 6 pi, minus 2 pi is 4 pi, minus 2 pi is 2 pi. Okay, now 2 pi is on the unit circle, it's right here. It's the same thing as 0. 2 pi is 360 degrees, so it's like one full rotation around the circle. The point there is 1, 0. So now I'm going to go in and fill in all of these values just like I did for the example on top. And I'll let you guys do that on your own. All right, these last problems are the same thing. So go ahead and practice those. And if you guys have questions, you can see Mr. Taylor after school, or you can wait until Monday and you can see me then. A reminder that next class period, you have a short quiz on the unit circle again. I'm going to ask you basic questions about sine of 30 degrees, cosine of 60 degrees, etc. You're also going to have to fill it in using the radians. And you also have a regular quiz next class. And your regular quiz is going to cover everything up to before we started the unit circle. So it's going to be like coterminal angles, reference angles, degrees, minutes, seconds, and all that stuff.